What you're looking at here is a drawing of something called a solid-state generator. The generator consists of a core, either ferrite or soft steel. Both types are used in other patents. Part B is a solenoid type coil with part A core inside. Part C being an addition of a magnet to create a stationary magnetic field. From here we can estimate the magnetic flux as shown in figure C. The theory is when a DC pulse is applied to the coil, the magnetic field is said to move forward. The forward flux is said to be a combination of the solenoid and the rear magnetic field supplied by the magnet. Thus, the forward motion uses a small current to shift the field forward, moving a stronger magnetic field. The force applied to the top magnet is then much stronger than a solenoid alone. Here is a patent drawing of something called an energy linear generator. By examining this drawing, it seems the same theory is applied. What really catches my eye is, according to the patent, it takes 1 amp to drive the coil and the output is 10 amps. Here you can see the areas that are familiar with the solid-state generator. The green box shows a stationary magnet attached to the back of the solenoid, the solenoid being highlighted with the red box. The idea here being there's a magnetic field shifted forward to cause an EMF in the pickup coil on the right. Let's look at that again. 1 amp in, 10 amps out. Well, look at that. That seems like over unity or excess power to me. Looks pretty easy too, doesn't it? Well, let's see if it is. Back to the solid-state generator theory. Time to set up something to really see if the magnetic flux is pushed forward and is stronger than just a solenoid. In figure C, I'm going to use a sensor to detect a magnetic flux. It's time to throw on my technical hat. Here's the setup I'm going to use to measure the actual magnetic flux change. I will use a computer to measure the flux and a pulse driver to create a pulse in the solenoid. The setup consists of our solenoid connected to a pulse driver. The capacitor used in the coil will provide a measuring point for an oscilloscope. The coil is driven with a transistor and the transistor is driven by a function generator. 12 volts will be our supply voltage. Our measuring device consists of a magnetic flux sensor. The sensor can detect the strength and direction of magnetic flux using a supply voltage of 5 volts. The analog output of the sensor, when no field is present, is half that of the supply. Depending on the direction of the flux, the voltage will change greater or less than half the supply. The USB interface card will receive the analog output from the sensor. The computer is used to read the voltage and graph the voltage change. Here's a screenshot of the software I wrote to provide a real-time graph. The graph will show whether any magnetic field is present and whether the field is changing. The graph can be saved at any time to compare measurements. Now for a look at the hardware. Here is the actual setup to drive the solenoid. Here we have our solenoid and our magnetic flux sensor sitting in front. And finally a shot of our USB interface board.